A 58 kilogram mass at rest on a horizontal surface is acted upon by two external applied forces. A 275 Newton force at 18 degrees up and to the left, and a 418 Newton force at 42 degrees up and to the right. The coefficient of static friction is 0.31. Will the mass move? Let's draw a free body diagram. There's our 56 kilogram mass. That has a weight equal to m times g, so 56 kilograms times 9.81 meters per second squared is 549.4 newtons. There's also a normal force. It acts upward. We don't know exactly what the magnitude of it is, but we know it points upward, normal to the surface. These applied forces must be resolved into parallel and perpendicular components. So the green vectors, the ones that are parallel to the surface, will be found by taking the forces times the cosine of the angles, and the vertical components will be found by taking the forces times the sine of those angles. 275 times the sine of 18 is 85. 275 times the cosine of 18 is 261.5 newtons. We do the same thing on the other side, again using cosine for the parallel to the surface direction, namely 418 newtons times the cosine of 42 will be 310.6, and 418 times the sine of 42 is 279.7. And then we have a static friction force. And the static friction force is going to help our 261.5 Newton force. You can see that 261.5 is smaller than the 310.6, so our static friction force is going to help the 261.5 Newton force. Okay, so let's sum our forces perpendicular to the surface. I'm going to choose up to be positive. Check your diagram to make sure this looks right. Normal force points up, 85 points up, 279.7 points up, but 549.4 points down. And the sum of those forces should equal the mass of the object, which is 56, times the acceleration in that perpendicular direction, and the acceleration is 0. We can solve this for the normal force to be 184.7 newtons. The maximum static friction force, the maximum force that's possible for any situation, is equal to the coefficient of static friction times the normal force. The coefficient of static friction is 0.31, that's given, and the normal force is 184.7. So the maximum possible friction force that we can muster in this situation is equal to 57.3. Now let's calculate what static friction force we need to keep the mass at rest. If we choose to the right to be positive and sum the forces parallel to the surface, we get 310.6 minus 261.5 minus Fs required, and that should equal the mass of the object times the acceleration parallel to the surface, which we want to be 0. In other words, if we want to keep this mass at rest, we need a friction force of 49.1 newtons. Well, the maximum that we can have is 57.3, so we do make it, but just barely. So the answer is no, this mass will not move. A 26 kilogram mass is on an adjustable incline. So if you see this picture, I've put a pin here, or a hinge, and so this plane can be made to rotate. The mass is at rest when the incline is horizontal, and remains at rest as the incline is angled more steeply. It is found that the maximum angle for which the mass stays put is 28 degrees. Find the coefficient of static friction between the mass and the incline. So in other words, we put this mass on this rotatable plane. We start horizontal and then we start rotating it. Up, 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 the mass stays there, the mass stays there, the mass stays there, and if we rotate it even a little more, then the mass starts to slide. The maximum angle for which the mass stays put is 28 degrees. Find the coefficient of static friction between the mass and the incline. Well, let's draw a free body diagram. The weight vector would go straight down. It would be equal to 26 times 9.81. But we want to resolve it into its perpendicular and parallel components. This portion will be 26 times 9.81 times the cosine of 28, and this portion will be 26 times 9.81 times the sine of 28. We also have a normal force that's holding the mass up, and we have the maximum static friction force. We know it's the maximum because we're told that this is the maximum angle for which the mass stays put, so obviously we've maxed out the static friction force. If we sum the forces perpendicular to the surface, we get normal force minus 225.2 is equal to the mass of the object times the acceleration perpendicular to the surface, which is 0. So the normal force is 225.2 newtons. If we sum the forces in parallel direction, if I choose down the plane to be positive, we get 119.7 minus the maximum static friction force, and the sum of those forces by Newton's second law should equal the mass of the object times the acceleration parallel to the surface, which is 0. So the maximum static friction force is 119.7. And the coefficient of static friction, by definition, is a ratio of the maximum static friction force divided by the normal force, 0.53.